experienced that as
3.4.1 exercise. Yeah. So if you notice, we're actually skipping 3.3 and 3.4. Yeah.
It's because
Well,
you did
no,
it.
actually, because it's been covered before, and like even with this skipping, right? Like what the goal is, like in terms of doing geometry, at least for this book, our goal is to finish chapter 6 by year 12, the end of year 12. Yeah. So that's projective geometry. Okay. So even with the skipping, it like it's not going to be easy to cover at all.
Or
Yeah.
does that just become a new topic over time?
But I mean, you know, we're scattering through it, and then if you really need bits and pieces, it's all recorded. So I at least want to do this stuff once, so that if you really wanted to do this other stuff, you can find it recorded. Yeah. But this stuff we haven't really recorded. So yeah. So Menalaus' theorem is basically telling you when 3 points are collinear. Okay. So when one line goes through 3 points, so you have a triangle ABC. Yeah.
Leo is about an inverted conical prism.
Okay, and the thing is,
That's
like,
a question
you need the X, Y, and Z have to be on the sides of the triangle, but the sides have to be extended because you can't have a collinear 3 points inside, right? So,
are you sure?
so you have like X extended here.
She wrote 4,096 to 8,000
And then-
equals to 4 to 5.
Here somewhere is like Y. Yeah.
Wait, who?
Whispers.
Bruh.
Well,
I mean, at least, like, does she teach math?
half the people didn't question it, and the other half like,
Yeah.
Hold up.
hold up.
Did she even
Okay.
do, like, a fox?
So the conditions given to you as this. So
4
it's
to
Bx
And 4,096
BX
to 8,000.
Oh,
on XC.
It's
Okay.
meant to be like 1 to
Wait.
2.
I'm only explaining this out of charity, okay? Because I'd rather just go through the exercise. So Bx on XC
Wait, what?
CY
No, come on, don't do this.
and YA
Okay, come on.
times AZ on ZB
Leo is dead.
Yes.
equals -1, okay?
Mine.
Yeah, so the -1, let's just, like, I guess I want to put it -1 because it makes you think, why is it -1, right? Why are lengths negative, yeah?
It's because of the direct.
Yeah, so this to remind you is directed length. So let's make that reminder early so that we don't figure it out later.
One way.
So what is directed length? It just means like Bx is equal to XB, minus XB, yeah? Bx is equal to minus XB.
What? Oh.
Yeah?
What?
So we're kind of writing them like a vector. Yeah? Does that make sense? So, for example, here, you see, like, let's define.
Leo is Leo was. Leo is from
Yeah. So can you kind of see like Bx? Bx is kind of in the opposite direction to XC. Yeah. So Bx is in the opposite direction to XC. So this ratio should be negative. Yeah. And then Cy is in the opposite direction to YA. Yeah. So that should be negative. Yeah. And then AZ is in the opposite direction to ZB. Yeah. So that's 3 negatives makes a negative. Yeah.
3 negatives make a negative.
Yeah.
Or it could just be 1 negative and 2 positives.
Come on.
Yeah, it's mine.
Does that make sense?
Yeah.
Okay.
You can't lock me out.
So let's look at the exercise
I'm a
now.
hacker. I didn't pass it.
What?
So this exercise is meant to substitute the lesson of Menalaus because I think it explains.
No.
So Menalaus is saying
Don't tell
if
lies.
that happens, okay, and they're
Lies
collinear,
are bad.
then this is equal to -1. Yeah.
You haven't worked
And
on it, but it's not
if you
cool.
just draw it, okay, and it's equal to -1, then they're collinear. Okay. Yeah. So there was lots of comments about it. So like for like Olympiad problems, they were saying like anytime you use Menalaus, you could probably do it with some other method, but it's kind of like it saves you. So like if you need to show something's collinear, and you have to resort to Menalaus, it'll probably get you there, but there's probably usually a faster way.
What if the marker doesn't know what Menalaus is?
What? You just tell them what it is. And then they can search it up if they
Just
actually
state
Yeah.
the theorem.
Yeah.
You state the wrong theorem.
Okay. So what was the question we had to answer? Yeah.
It's like the genius move.
So remember we said the external angle bisect. So this is also going to cover the in-circle thing that you guys missed as juniors. So
Wait, didn't you really do that? Wait.
So there's an in-circle principle that I want to explain. I hope did I explain it last time as well?
No, I was thinking about the other way quadrilateral circle question.
Yeah. Maybe I did explain. Anyway, so remember what was the
That's his brother.
so a triangle, yeah?
Unlucky.
Let me draw another color. So you have a triangle. It's a scalene triangle, right?
Yes.
And then this will be the vertices of the triangle, yeah?
That is.
Yeah? Okay, so the external angle bisector, the internal angle bisector is like this one, right? The external one's that one. That make sense? So that's like the external angle bisector. Yeah?
Okay.
This is the external angle bisector.
Subtle much.
And this one is an external angle bisector. Okay? And we're trying to, we're not meeting them with each other. We're meeting the angle bisectors with the opposite sides. So at that vertex, okay, so let's call it like ABC, yeah? Yeah? We want to meet this angle bisector,
Oh, bro, the diagram's like messed up now.
yeah, like here, yeah?
But just look at this man's face.
Yeah? And the one at B is meant to meet AC, yeah? Like here, yeah? Okay, let's see the other one. Okay, so this is going to meet like somewhere over here off diagram, yeah? And then the claim is these three are in a line. Yeah? Okay. Did you get any progress here? So I guess in the context of this exercise, we're trying to calculate this, yeah?
Yeah.
Makes sense? Okay, so what is it that we're calculating? So this is, so X, maybe we can do Y. So which one was the one that, Y is the one that was an AC, right?
That's like my actual representation.
X,
Is there room?
yeah, maybe it's the wrong way around.
For Christ.
Let's forget the signs for a little bit and just focus on like the ratios, cancelling the plus or minus one for now, okay? So we don't have to be too careful. So if this is Y, yeah? How do we figure out YA? Jeez.
What?
Alright, you have to remove the chairs from the room now.
Okay. That's the punishment. A very good punishment.
And he should be punished. So, actually,
No, the thing is like there's natural punishments for everything. Okay, so Y, you need to calculate like YA on CY, yeah? CY, you need to find CY and YA. Yeah? See that?
Yeah.
Okay. Okay, so there's one idea, okay, that's really important. There's one idea that's really important, okay? So when you have angle bisectors, okay, this idea is really important. And with this idea, all the theorems about angle bisectors are obvious, okay? So with angle bisectors, so if you have a triangle, right? Or maybe not even a triangle, just two lines, yeah? They make an angle. And then you have an angle bisector, yeah? Yeah. So can you see the angle bisector has the property that it's equidistant from the two lines? So that's kind of obvious, isn't it?
Yeah.
And you can prove it with like congruent triangles, but it's kind of obvious because it's the point that's it's the line that's in between the two lines, right?
Yeah.
So it should be equidistant to the two lines. So like knowing that actually proves a lot of things. Like for example, you know, in circles exist because the angle bisector it's equidistant from these two lines, right? So when it intersects the other one, it's equidistant from all three lines. So that all three angle bisectors intersect, yeah? So something similar works here. So
you need to take a photo of that.
alright, so if you look at Y, yeah?
How do you even make it that long?
So Y comes from the external angle bisector B, yeah? Does that make sense? Yeah. So that means it's equidistant from the side AB and BC.
Wait,
What?
Yeah?
Oh yeah.
So BY is the bisector of angle B, yeah? So it means it's equidistant from AB and CB, yeah? Huh? What?
He said why?
Yeah, the letter Y is confusing here because
Why?
Why? Why?
Why is equidistant?
No,
Because
he's
it's a
actually
bisector.
asking a question.
what did I say just before this? Angle bisector has the property that I'll
Like
explain
any
why.
point
Okay,
on the
so
bisector.
so this is angle bisector, so these angles are equal, right?
Yeah.
So if you look at any point on this line like here, yeah?
They're equal to the
What does
other.
distance mean? I mean perpendicular
Yeah,
distance,
they're
right?
equal.
Perpendicular distance.
Oh,
Okay?
genius.
And
move.
because it's perpendicular and the angle is equal, it's AAS, right? It's a common hypotenuse.
Slap.
So that means this is also equal and that's equal,
Oh.
right? So it's actually equidistant. Yeah?
I mean,
Yeah.
whenever
Okay, if you
draw
ask the
line,
exact
you
same
actually-
question now, it'll be awkward.
But why?
But why?
Holy crap.
Okay, so it has the same distance from BC, right? Let's call it H, yeah?
Oh.
Yeah?
Yes.
As it, well, I mean, it's connected to that, so we don't know about that. And it has the other distance, say like, maybe what's the distance look like here? Yeah, it's H. Yeah.
That does not look very
That's
equal.
What?
That doesn't look very equal.
No. Like the letters are the ones that look equal.
Oh, H is equal to
Yeah,
H. Oh
okay,
shit.
equal.
Okay, so if you draw in the H's, right? Can you see that
Y is equal. Big brain.
YA, right?
Wow.
No, it's not. I'm big high. I'm joking.
Where's the angle?
I added it twice, so it's scam.
Okay, so can you see that
Now
sine
equal.
C, right? Sine C
Yes.
is H on YC, yeah? Or CY. So so YC.
No.
CY is sine
Yes,
C.
No.
yes.
No.
Yes. No.
Yeah. So CY sine C is equal to H, yeah? So sine C is this C, yeah?
Ah, come on. Actually,
Hey, chuck me that. Patch.
my patch. No, not this one.
No, look at that. I'm lucky landscape from gaming. Yeah, you didn't get that. You didn't get it. How would you get it? Oh yeah, actually no, I wouldn't even.
True.
That's what I was gonna say.
Yeah? Are we all good?
Yeah.
So can you also see that YA, so it's sine A here, right? Is equal to H on YA.
Whoa.
Sine A is equal to H.
I know what sine is.
You see that?
Ratio of
Yeah.
opposite on hypotenuse.
Alright, so if everyone sees this, I'm gonna just keep going, yeah?
Yeah.
Oh.
Yeah, we get that.
Yeah?
Yeah.
So basically the stuff that happens with Y, yeah? So it's Y is A and C, right? You get sine A and sine C, yeah? And the same H, yeah? So if you do it for the other things, it'll be similar, yeah?
Wow.
So you get like XB, for example, yeah? So BX sine B, yeah?
Huh.
Will equal, maybe I'll do HY here, yeah?
Huh.
HX, yeah? And XC sine C
Check me the pen paper.
is equal to HX also, yeah? You see what I'm saying here?
Yeah.
And then last one is AZ, yeah? Sine A equals HZ. And then ZB sine B, yeah?
Check in the
Is equal to HZ, yeah? Yeah, so what happens when you
I
form
see
the
the
ratios
values.
now? Can you see if you divide cy by ya, right? You get basically you know, yeah, sine A over sine C. Yeah? So you get sine A over sine C here.
Oh.
Yeah?
Yes. Yeah, that makes sense.
So if you divide these two, AZ by ZB, you get sine B on sine A, yeah?
This is genius.
And if you do BX on XC,
You have
you get sine C on sine B, yeah?
wait.
G
BX.
on G
And so they all cancel out.
on G.
And kind of by what we were saying before, like the way it has to be on the outside of the triangle like that, there should be like negative, negative, negative.
What are you doing? What are you actually doing?
Does that make sense?
Yeah.
Yes.
See, because now the point is, if you can get A and C here, that's A and C. You get B and A, then C and B, and they all cancel, right? Sine C cancels sine C, sine A cancels sine A, sine B cancels sine B. Is that good?
Everything else exactly.
So that means I don't need to explain the next exercise, right? The next exercise looks kind of similar, you see?
The internal part thing you do.
So it's internal angle bisectors found.
Okay, draw the diagram clearly.
Okay?
Wait,
So maybe that one, if you want to like do it yourself and you want to go through it, we can do it, yeah? But I'm not going to mention it without prompting, yeah? Okay.
I'm gonna replace it